Good evening. Today we will start about the and we will further discuss about the resistance spot welding. In the last week we studied that we can optimize the weld nugget geometry by the weld growth curves. The weld growth curves are generally drawn between um, current or time versus weld dia. So the curve shows like this, and at I max, the the well diameter reaches a value that the expiration of that uh, joint starts. So this is the maximum point we can achieve the weld nugget diameter. So in today's class we will discuss about the tensile test, the mechanical testing of these resistance spot welds. So uh, the first is mechanical testing is the uh, um, simple tension test. The simple tension test diagram is shown in the figure A. Means only the tensile means the that spot well is is made to stretch from the two directions within the base material. So in this test, the base material properties also include. So what we get from the tension test of this spot wells. So generally, the stress required to break the weld joint apart and the maximum strength this weld interface can withstand. Uh, so the in simple tension test, we measure the stress required to break the weld joint apart. So the simple tension test of the resistance spot welding is done to find the stress required to break the weld joint apart. And maximum strength uh, the weld interface can withstand. So the as we know that the base material property means strength is also included in this test. So in order to identify what is actual property of the weld apart from the strength and ductility, we also look at the plug ratio. So in order to identify property of the weld apart from strength and ductility. We also look at Poisson's ratio, sorry, plug ratio. So plug ratio we measure after the uh, failure of the nugget is intact or not. So the plug ratio tells us that after failure, the weld nugget is intact or not, and it is given as the uh, means plug ratio is equals to plug size after testing divided by the weld nugget dia. The plug is generally uh, the weld joint left after the failure. So this is the plug ratio, and um, the solution for the to remove the mechanical properties of the base material is to use uh, the second means to change the solution we can remove the effect of the base material is to do the second this cross sectional tensile testing, cross tension test. So the in the cross tension test the majority of load is applied to the weld, so that's why it is the more accurate. And the very common use this cross tensile tension test is the more accurate and very commonly used in order to get the weld joint mechanical properties. So it is very commonly used test. Third third test is the tensile shear testing in which the so in this test also the um, weld means weld nugget strength can be measured accurately. So this is the how means there are two conditions of failure of the weld joint. So in the first case, the weld joint failure occurs from the weld nugget. Well, in the second case, the weld nugget is safe, and the failure happen from the base material, and the uh, interface of the failure in this first case is also that the some part of the welded joint is left, and in the second case the complete weld nugget is left after the testing. So the the required plug ratio for a better resistive spot welding joint is the uh, it should be around 80%. 80% or zero point 0.8. So the plug ratio can also be uh, optimized by the curve of the plug ratio versus uh, current time or weld dia. So by optimizing the current time welding time in weld dia, we can ob obtain the 100% plug ratio, 100% or 1. Uh, in this diagram, which is drawn between the tensile shear force versus weld nugget dia, and this is the thickness of the uh, base plate. So for a higher thickness, the tensile shear force applied to uh, to break the weld joint is higher. Means the high means much thicker weld section need the higher tensile shear force to break the weld joint apart. So the overall strength, the uh, the the main point of this tensile testing of the plug weld joint dia is to identify strength. Means we generally identify the strength required to break anywhere from in the component plus the plug size. So we identify strength required to break anywhere. Means it can break from the weld joint or from the base material plus the plug ratio. Means what is the plug size? Remain after the testing. And generally the means what is the reason of the failure of this weld joint. So if we see this, the weld nugget geometry, means this is the weld nugget and this is the base plate. So we can find that there is a notch present at the weld nugget position. So this notch is then lead to a failure of the material. Weld joint lead to failure. So the um, means the means the geometry of this notch is generally referred to the sharp impact test specimen. Means this is the uh, sharp impact specimen used. So the notch geometry at the weld joint is similar to this sharp impact specimen uh, geometry. So this lead to the uh, so this can uh, lead to the means this can also tells the uh, ductility and toughness of the welding joint. Means we can conclude the what is the ductility and toughness of the of our weld nugget. So what are the typical problems? So what are the typical problems we can face during the testing of the weld nugget joints? So the problems can occur from the different sections, because so first problem can occur from the change in process window for small changes in composition. Means change in process window with chemical composition. Means if the chemicals composition of the electrode or the welding material changes, then we have to optimize the current and welding time and the weld nugget dia to obtain the a good welding joint. Second point is the electrode life with zinc coating. Means the zinc coating done on steels. So the zinc diffusion can happen into the copper electrode, and that can reduce the life of the that copper electrode by changing its composition. The third point in the problem is from the poor fit up parts. Means if the electrode and base materials are not placed at the exact position, then it can also hamper the welding joint strength. Fourth point is the access problems Access problems means the electrodes can only reach the um, in a straight position. Means this is condition is the ideal. If if these have the curved surface, then the reaching of this electrode at the bottom will be difficult. Fifth point is the electrode skidding. Means if electrodes placed at the base material sheets skid, then this also lead to the change in welded nugget dimension and the position of that weld joint. Next is the means resistance is in, spot welding of aluminium alloys. So there are different problems associated with the welding of aluminium alloys. First is the high welding current needed. Due to low electrical resistance. Second point is the narrow plastic range between softening and melting parameters. And melting means the softening and melting point of the aluminum alloys are very near to each other. So we have to control the current that in such a way that it does not melt and only soften. So this should have be controlled carefully. Then the oxide film should be removed for better weld quality. The point is the careful control of electrode force is necessary to avoid cracking. So these are the typical problems facing in the resistance spot welding, and the variation of the sample strength uh, with base material strength resulting in the different uh, failure uh, failure features is the shown in this picture. Means as the base material strength is increased, so there are two types of test. Means for in the first test, the base material strength is also including in the test. For so this is shown as the green color. So with the low base material strength, full plug uh, failure occur means the plug ratio is high and with this high sample strength. And in the second case, where as the base material strength is increased, so the failure will happen at the interface means with increasing in material strength means we have to add alloying elements for increasing the strength. So those alloying elements uh, segregate at the weld interface, making that interface brittle. So the failure will occur at that point. While in the cross tension test, the with low base material strength, full plug failure will occur, means the plug ratio will be 1. And as the base material uh, strength increase, the plug ratio starts to decrease, means this is the also good fail comes in the good failure, but with increasing the material strength above 600. So this data is for the steel. So partial interface failure happens with increasing the material strength. So this also leads to the means the increasing alloying elements make the weld interface brittle. Now the second scenario of the problems occurring in the resistive spot welding are the uh, difference in dissimilar thicknesses and thermal conductivity. So for the E case, where the so in the E case, the both materials, thin and thick, has high conductivity. In B case, in the case B, the both thin and thick sections have low conductivity. And in the uh, case C, both plates are of same thickness, but the material is different. Means the upper plate material has uh, high high conductivity, where the lower plate has low conductivity. So we will see these three cases one by one. So in the first case where the dissimilar thicknesses having the high conductivity, so the uh, uh, so we can see that the welded nugget shape is also is deeper in the thin section. So what happens with this means this is the both materials have high conductivity, but the thicker section will also generate the mass effect. So due to mass effect, the heat conductivity will be high, and in the thinner section, the heat conductivity will be low. Means heat conductive capacity will be low. So the weld bead will form in the thin section. While in the second case, where the both materials have low conductivity, so the thicker section has low conductivity and thinner section has low conductivity, but the thinner section able to conduct the heat much easier. Means in from the thinner section the heat can escape easily, and the means the low heat capacity of the thicker section uh, leads to the formation of the deeper well bead in the thicker section. Means this cannot conduct the heat easily. While in the second case, where the uh, both plates are of the same thickness, but the material is different, so the weld bead will form in the low conductivity material. So these problems we can overcome by changing the electrode area. Means if we choose the uh, greater greater cross sectional area of the bottom electrode, then then the resistance and conductivity resistance and current supplied from the bottom electrode will increase, so that will lead to the uniform geometry. Means the this dissimilar weld bead can be overcome by using larger cross section electrode. So as the contact area high, so that will lead to the formation of the uniform weld bead. And we can choose the low conductive materials for the other electrode. Larger cross sectional area and low thermal conductive electrode. Next problem happens in the resistance spot welding is the shunt effect. So the shunt effect comes when we use the direct current. So because of the direct current, means the electrons wants to follow the least resistance path with the uh, previous welding joint. Means in this case the DC power source is connected, so the electrons will also uh, travel from the previous weld, leading to the less current supply to the uh, uh, means current supply to the uh, weld joint, second weld joint. So because of the less current supply, the weld bead will not be much effective or with good geometry. So the diversion of the welding current from the weld to be made to a nearby existing weld, decreasing weld diameter. So the weld diameter of this second joint will decrease due to this shunting current uh, release. So this problem can be overcome by using AC current or changing the polarity. In this case, we should be very careful with the position distance between two welding joints. Means if we maintain a safe distance between two welding joints, then and using the changing in polarity or AC current, the shunt effect can be reduced. So this shunt effect is generally uh, predominant in dissimilar metal welding. And second point about this shunt effect, this leads to erosion corrosion, electrode erosion. Means the DC current is very high uh, amount, so the electrode can erode with time. So the only remedy for this is to change polarity, or we can use AC currents also. So in AC current, the polarity gets changed by with every half cycle. Yeah, so in the second case, the Peltier effect in DC source is also shown. So this is the copper electrode and aluminum. So spot welding of aluminum direct current. So in this case also, the welding. So because of this, uh, the welding joint can happen at the electrode base plate interface. Means the current supply at the welding interface, means base plate interfaces, are very less, and the resistance got increased at the electrode and base plate interface. So this is not desirable. And in aluminum also we have the high conductivity. So at the interface, very less current is available to uh, for the welding joint to make to make the welding joint. Next is so this is the problems are completed for the resistance spot welding. Next is the resistance brazing. Yeah, so this effect we just seen in this case, where the welding joint is not happening at the base plate interfaces. So what we can do, like to apply a filler material between the base materials. So the this filler material has the low thermal conductivity and low melting point. So this by you introducing this filler metal wafer, which is flux coated, leading to the good welding joint between the base plates, and this also leads to the uniform complete welding joint with the base material with the base metal sheets. So because of this resistance spot welding, the advantage of this resistance brazing is the welding of small flat plates, small flat parts can be easily done. Next point is the welding of large parts. Means the welding joint area is very large, so this can uh, apply to thicker materials also. So this is the first case. The small workpieces are used, and the filler metal wafer is inserted between these two metal sheets. In the second case, where large parts are required to join, so the uh, bigger electrodes are used, and in this, small electrodes are used. The filler material uh, we can use in this resistance brazing is the uh, generally the silver alloy. So for making the welding joint for the stainless steel, heat resistance alloy, copper alloys, and nickel alloys, the silver type filler metal alloys are used. While for the aluminum alloys, aluminum silicon uh, alloys used, and for copper and copper alloys, copper phosphorus uh, filler is used. So why we use this type of filler metal alloys? Because these filler metal alloys has a low melting point and low conductivity. So the welding joint can be easily made by using these filler metal alloys, and the aluminum silicon, uh, also known as the eutectic alloy. So the specialty of eutectic alloy is that they have a very low melting point compared to their uh, single elements, compared to other uh, aluminum alloy variants. So generally the eutectic alloys are used for the resistance bracing weld joint formation. Next, next welding is the uh, resistant seam welding. So in resistant seam welding, continuous uniform weld joint forms. Or where we can say the welding spots are formed. Means these are the continuous welding spots. So this is generally carried out by using roller electrodes. So the base material are fed to this resistance seam welding roller electrodes, and as the it further progresses, the welding this is the travel direction. So the welding spots continue to form by with the moving of this base plate and roller. So the main application of this resistance seam welding is the main in the fences, corrugated roofs, and thin sheet welding is easy. Means thin sheets can be easily welded in the resistance seam welding is easy. So this is the variant of resistant seam welding. So first is the circular machine, where and the second is the longitudinal machine. So in the circular machine, the base metal sheets are uh, introduced in the rollers with side. So this is the upper electrode wheel, and null or friction drive wheel is also provided for the means support. So this is the workpiece. So first is the circular machine, and second is the longitudinal machine. Means the longitudinal weld is formed in this type. So the variance between the lap seam, there are different types of seam joints. So the A case where the roller electrodes are used. So this leads to the lap seam joint. In the second case, where the mesh seam is provided, so we first make the lap between the two metal sheets by putting the second sheet over the one with the edge, and as the uh, roller roller electrode applied a force, so that this leads to the this mesh seam. This the seam joint generally happens in this like that. And while in the second case where metal finish seam welding is done, so in this welding means the before welding these sheets are put like this, then after means the upper electrode has less cross section, and the bottom electrode has a larger cross sectional area. It's broad, flat, and the first second is the chamfer electrode. So the Parsh means this type of uh, seam welding joint can be formed um, in this process. Next is the projection welding. So projection welding is the next variant of the resistance welding. In the projection welding, projections are made to a sheet, and that projected sheet put on the second sheet. Then the force is applied by the electrode with current. So the current supplied and the force applying on the projected sheet. lead to the melt means the uh, smooth smoothing and the mechanical deformation. So in this process, the softening and mechanical deformation helps in the uh, welding joint formation. Weld joint. So in this process, the current required to form this weld joint is less because the mechanical deformation also assisting in forming this welding joint. So the projections made in the sheet helps in projection helps in concentrate the heat at one point. So this process do not need higher current to melt entire interface. Means in melting the entire interface, we will need higher current. But in the projection welding, the heat concentrated at one point. So this will lead to less current supply, means less dependence on the current. The mechanical deformation assist in weld formation in weld joint. So uses of the projection welding are in dissimilar thicknesses. The dissimilar thickness sheets can be easily welded by using the projections. The various geometries can be created and laminates can be formed. Means multiple sheets can be welded with at a time, and the stud fasteners are also joined by using the projection welding. So the projection welding also lead to the multi-spot welding. Means the projection welding can be also named as the multi-spot welding. Next is the flash welding. So in the flash welding, first the two rods or the two tubes come are kept at a distance to form the arc. As the arc strikes between the two rods, the interfaces starts to melt and colloid. So with the collision of uh, this the two melting interfaces, the welding joint forms, and then the one of the rods is pushed to the second uh, pushed towards the second rod to form the butt joint. So flash means, so this is also known as the flash butt welding. Means first the arc is ignited between these two rods to melt the interfaces. Then these interfaces are pressed to each other to form the butt. So this flash welding is generally used in the wheel making process. Used in wheel making or wheel rims. Wheel rims are made by using these flash butt welding. So the force applied here is known as the upsetting force. So uh, sometimes the resistant upset welding and the flash welding are confused with the term of this upsetting force. So the main difference between the resistance upset welding and the flash welding is that in flash welding we strike an arc between two rods, but in resistance upset welding we do not use arc. So this is the resistance spot welding setup, upset welding setup. In this, the two rods or tubes are put in contact, and that power source are connect AC power source will connected to these two rods ends. So with the resistance applied at the interface, joining interfaces of these two rods or tubes lead to the melting of the interfaces, then lead to the for and as the some force is also applied, means there's also upsetting force from this side will lead to the formation of this butt weld. So this welding is done in the solid state. And the criteria for this resistor substrate welding is the part should be of identical cross section. Parts of identical cross section means the diameter of the two parts should be same to form the butt joint. Otherwise, the welding joint cannot be made. So this upset welding is ideal uh, for welding of small wires, tubing, piping, rings, and strips. And the in the resistant upset welding, The interface preparation also needed. Interface should be prepared. While in the flash butt welding, where arc is strike between the two rods, so because of the arc strike of an arc, the there is no need to prepare the welding interfaces. Means the any impurities present at the interfaces will goes out in the but outer section, and the but extra but shape can be removed further after formation of the welding joint. So in this surface preparation is not needed, not be prepared, while in the resistance upset welding the surface should be prepared. So the one problem in the resistance upset welding is the poor alignment. Next is the so this is this setup of means the resistance upset welding. The uh, these two welding rods are put into contact with each other, and as the butt weld forms, the butt oxide uh, oxides or any inclusions present at the surface will come out with this portion. Means metal will flow outward, and that displaced metal during upset uh, contains the generally oxide or inclusions. So this can be removed after the welding. Molten metal extruded after the weld. So the typical problems means the happening because of the poor alignment. So if the alignment is not proper, this alignment types, this leads to the slipping of the welding joint after welding. So this is the called as the poor alignment, and this is the good alignment. Next is the percussion welding. So the percussion welding generally done by rapid release of electrical energy, energy. So the time is very less in this process, around 20 millisecond. So this percussion welding is done for small parts with dissimilar thicknesses, or dissimilar or metals. Means dissimilar metals can also be joined with this percussion welding. So the use of this percussion welding is in the welding of means welding studs of vehicles. So the release of electrical energy comes from the capacitor used in the um, wire feeder. So as the wire comes in contact with the sheets, sheet or the another material, so while the contact, the capacitor releases the electrical energy. So that is also a very high amount of electrical energy within a very less time. So that a high amount of electrical energy uh, from the welding joint at that point. So the gun is generally used to uh, uh, pro- provide the uh, welding studs to make the welding joint at the vehicles. So this is all for today's class. We will discuss further more welding in the next week. So thank you.